Welcome to The Explainer. Today we're jumping right in to turn a pretty complex chemistry exam question into clear, totally achievable points by, well, getting inside the mind of the examiner. Have you ever wondered what an examiner is actually thinking? Well, today we're not just going to answer a question. Nope, we're going to reveal the secret code to getting full marks, and we're going to do it by using the official mark scheme. This isn't just about memorizing facts, it's about understanding the rules of the game. Okay, let's dive right in. We're putting two super important documents side by side. On the left, you've got the question paper, the challenge. And on the right, that's the official mark scheme. Think of it as the code that unlocks every single point. All right, first up, we've got question 06.1. And this one is all about a classic practical test used to identify that key feature in cycloalkenes. You know, that double carbon-carbon bond? So the question itself is really direct, right? It's asking for two distinct things, which of course means there are 2 marks up for grabs. First, describe the test. Second, give the result. Simple as that. And boom! This slide shows you exactly what the examiner wants to see. The mark scheme just lays it out perfectly for 2 marks. For the test part, you just write, add bromine water. And for the result, it changes from brown-orange to colorless. It's really that direct. Now, this is the part you really got to pay attention to. Precision. The mark scheme is super specific. It says the start color is brown or orange, and the end color is colorless. Just saying it changes color or goes clear? Nope, that's not specific enough, and you won't get the mark. The details really matter here. Let's keep the momentum going with 06.2. This time, it's not about a lab test. It's about spotting a mathematical pattern in the chemistry. So we're kind of swapping our lab coats for our thinking caps on this one. The question gives us 3 examples to work with: C4H6, C5H8, and C6H10. Our job is to find the general formula. Basically, if N is the number of carbons, what's the simple rule to figure out the number of hydrogens every single time? And there it is. The mark scheme confirms the 1-mark answer is just CnH2n-2. Let's do a quick check, why not? For C5H8, if N equals 5, then 2 times 5 is 10, minus 2, yep, that's 8. It works perfectly. 1 mark in the bag. Okay, now for a visual challenge in question 063, completing a chemical structure. This is where you really get to show that you understand how these reaction mechanisms actually work. So the key thing to remember here is what happens in an addition reaction. That double bond in the cyclohexene molecule, it basically breaks open, creating 2 new little docking stations for the 2 chlorine atoms to attach themselves to. And here we go. This is the most common correct answer, pulled straight from the mark scheme. See how the 2 chlorine atoms have just added on to the adjacent carbons, right where that double bond used to be? And notice, all the other CH bonds are completely untouched. But wait, this is where it gets really interesting. The mark scheme doesn't just stop at the most obvious answer. As you can see, it also accepts these other valid isomers. Now, this is a crucial insight, you guys. It means the examiner isn't just hunting for one specific answer, they're looking for any chemically correct structure. It shows there's some real flexibility in the marking. And finally, let's tackle the 3-mark calculation in question 06.4. This is the kind of question where showing your working is absolutely essential if you want to pick up every single point available. This is a classic percentage composition question. The formula is pretty straightforward. You find the total mass of the chlorine, divide that by the total mass of the whole molecule, and then multiply by 100. The mark scheme gives us the exact pathway to lock in all 3 marks. And here is that exact pathway broken down into 3 clear steps for us. The first mark is for getting the relative formula mass right, which is 153. The second mark is just for setting up the division correctly. That's 71, the mass of 2 chlorines, divided by 153. And that third mark, that's for nailing the final answer. Follow those steps from the mark scheme and you land right on the money, 46.4%. And hey, here's a little pro tip. Even if you somehow messed up the calculation in step 1, you can still get what are called follow-through marks if you use your incorrect number correctly in the next steps. See? That's why showing your working is so important. So what's the big lesson here? It's that the mark scheme is your most powerful revision tool. It's not just a boring old answer key, it's your roadmap. Understanding its structure, the level of detail it demands, and where the marks are actually awarded is just as important as knowing the chemistry itself. By using the mark scheme as your guide, you're not just learning chemistry, you're learning how to prove you know it
It really is the key to turning all your knowledge into guaranteed exam success. So, what exam question do you think we should decode next?